Welcome to the first part of the Best Robotics Programming tutorial series. This is going to be the basic introduction. We'll just get right into it. So to start off with, how do you control the VEX robot? The VEX robot is controlled by the cortex. It receives commands from your programming code and it executes whatever's in the code. To send the functions to the cortex, you need to compile code to the robot from one of the compilers, such as Simulink or RobotC. You can find a list of all the functions that you can send to the robot in the libraries, pictured to the right. Simulink and RobotC are slightly different, and they have different types and amounts of commands and functions. So let's get into that. Simulink is very different from traditional programming. It's a powerful simulation tool and has pre-made code functions. Simulink is both a graphical and text-based program compiler with a proprietary programming language called MATLAB. RobotC, on the other hand, is easy to use for previous programmers. It's simple but limited in features. It is text-based but also has a graphical implementation. It uses the widely known C++ code structure, which means it's super easy to look up, help, and get answers from other people. So what is a text-based in graphical programming? So text-based is much more flexible and you have finer control of the robot. And for example, this is RobotC and you can see that it's all just, you type out the text. It allows you to format whatever way you want as long as you don't have any errors. So for graphical programming, this can be a lot simpler for those who are beginning. There's like no syntax required. You can drag blocks wherever you want. It usually will never give you an error. So it's a lot less debugging for beginners and a lot less of a headache. And it's color coded, so it's easy to visualize and see all the code and how it works. So Simulink is very different and it uses block diagramming and state flow. So block diagramming is what you see below, and that is where functions are blocks connected by arrows. As you can see, starting from over the X, it like follows this line, goes into the sum block, etc. It's non-linear, which is very interesting to note because functions can be performed simultaneously and run at different speeds. So you can have code that is running and then have separate code that is running at a different rate. This would be like moving forward and turning at a certain time versus checking where you are on a line with a light sensor. So you can use this really well for continuous calculation, like cruise control in a car, where it's continuously taking sensor logic, feeding it back into the robot, and controlling it. What it's not good at is doing things at a specific time. That's where stateflow comes in. So stateflow programming, as you can see at the top right, it is similar, but each state can hold several functions, not just one. They're still connected with arrows, but the arrows are only activated once the condition on that arrow is met, like an if statement. So mostly used for time-sensitive operation, like say an alarm clock. It fills in the gaps where block diagramming doesn't work, so it can store and read variables, which is super important when doing any type of programming. Block diagramming doesn't quite store and read variables. It can have a thing, it's called like data in and data out, but it's really not the same. You can add delay to your program. You can change the behavior of the robot, which is really helpful when doing autonomous versus driver controlled. It allows you to like completely switch around the logic in your robot. Here's a close up. As you can see, there's these blocks and it has a title at the top. You have your functions. Then you have the if statements to switch states. Thank you for watching. If you have any questions, please leave them in the comments. I'll be happy to answer any of your questions.